Hi, this is Keertana. So this is the final project for pattern recognition. This project is mainly about the comparison of various techniques on multiple parameters for handwritten digit recognition. This is the overview of my project. So basically, what is handwritten digit recognition and its applications? The MNIST dataset, which is the input dataset for this project. The overview of machine learning techniques used for the handwritten digit recognition. So basically, there are K nearest neighbors KNN, random forest classifier, support vector machine, and it also involves the experimentation on results. So finally, I'll be showing the demo of the project. So basically, digit recognition is a field of pattern recognition as well as image processing. So this digit recognition system is nothing but the functioning of a machine to train itself or recognize the digits from various sources such as bank checks, papers, images, etc. There are various real-world applications for the handwritten digit recognition, so such as processing bank check amounts or for online handwriting recognition on computer tablets, also to identify number plates of vehicles. But the major problem with recognizing the handwriting digits is that they're not always of the same size or width or orientation. So they differ from writing of one person to other person. So this general problem would be while classifying the digits due to the similarity between the digits such as like 1 and 7, 5 and 6, 3 and 8, 2 and 5, etc. In this project, I have used MNIST dataset. So this is nothing but a subset of NIST. So without changing the aspect ratio, the data is formatted to a 20 to 20 pixels. This dataset consists of around 70,000 labeled images, out of which 60,000 are in the training set and 10,000 are in the testing set. Both the training set and the testing set contain labeled images from 10 digits, which is 0 to 9. So these handwritten digits are processed and provided as images in the form of 28 into 28 grayscale intensities. And the file format which is used to represent MNIST dataset is IDX. This is very convenient format, and as a part of the description column, the magic number is provided at the top. A magic number is the direct usage of the number in the code. So usually it considers an integral value in which there are zeros in first two bytes. So in the third byte, it represents the type of the data such as integer, float, short, long, or unsigned type. And the fourth byte represents the dimension of the vector or matrix, which is like number of rows and columns. The MNIST data file is read as a binary file in the Python code. So the magic number is available for each file. So these data files, which are for like two of training dataset and two of test dataset, these are loaded serially by ensuring that like the corresponding magic number condition is met. For instance, the file that contains the labels, be it training dataset labels or the test dataset labels, the magic number should be 2049 to load and read the data. If the condition is not met, then an error is thrown. The details about the number of rows and columns are read from the data files, and this would help in reading the 28 into 28 data and the corresponding labels for this data. In this project, several methods are used for the handwritten digit recognition, and multiple parameters are being compared in all the approaches. So the different machine learning techniques include KNN, SVM, and random forest classifier. So all these approaches are implemented in Python, and several experiments are carried out on parameters like accuracy, confidence, error rate, and the training and testing time for the handwritten digit recognition. So let's first see about the k nearest neighbors approach. So this KNN is one of the simplest machine learning algorithms. Given n training vectors, KNN identifies the k nearest neighbors of C regardless of the labels. This algorithm classifies the data by calculating the distance between the label data point and the new data point. So this distance can be like Euclidean or Hamming distance. The steps involved for k nearest neighbors algorithm in this project is that basically the firstly MNIST data is loaded, and then this data is split into test and training datasets using cross validation, and then the KNN algorithm trains the classifier. So in the Python code, the k neighbors classifier needs the number of neighbors algorithm and the number of jobs as input. This classifier trains the model with the input training data images to the corresponding labels. Thereby, several metrics like confidence and accuracy are displayed. This accuracy is calculated by comparing the predictions using the KNN with the training labels. Moreover, the labels are predicted for the test data as well, and this results are compared with the test labels. And finally, the percentage of the accuracy for handwritten digit recognition is displayed in the confusion matrix. Moving on to next approach, which is random forest classifier. This is one of the most popular and powerful supervised machine learning algorithms. So both classification and regression can be performed by RFC. And as the name indicates, the algorithm creates a forest with number of decision trees. In general, it is said that the more the number of trees in the forest, the more robust is the prediction and hence the accuracy. Multiple decision trees which are used for classification are formed using batch of input data in the form of matrix. This decision tree classifies the test data given as the input, thereby the class to which the data belong is predicted. Based on the result from all the decision trees, the majority is taken as the prediction class. Coming to the steps involved in the code. So the steps are very much similar to the KNN classifier, except that the random forest classifier needs the number of trees in the forest and the number of jobs as the input. Moving on to next machine learning approach, which is support vector machine. This is best suited for extreme cases in dataset. So basically it draws a decision boundary, a hyperplane with extreme points. So SVM is a frontier with which best segregates the two classes by using hyperplane or line. So, and also it is said that unoptimized decision boundary could result in high misclassifications on the new data. So in SVM algorithm, the support vectors are crucial, whereas the training examples can be ignored. And the steps involved in the code for the SVM classification is similar to the other approaches, except that the SVM classifier needs the gamma and the kernel as the input. Moving on to experimentation and results. So the three machine learning methods KNN, RFC, and SVM are compared in terms of accuracy, error rate, confidence, and the training and testing times. So the time taken to recognize the digits is one of the key factor ideally. So the recognition system should take as minimum time as possible to identify the handwritten digits in the practical applications. So as shown in the graph, for KNN, the training and the testing times are 14 minutes and 7 minutes respectively. For RFC, it's 9 minutes and 6 minutes. And for SVM, it's 15 minutes and 9 minutes. For the handwritten digit recognition applications, the accuracy is one of the most important metric. So like any misinterpretation or misprediction might lead to like adverse results. Hence, care should be taken to predict the data as accurate as possible. So the graph shows the accuracy for different classifiers. It shows both the training and test accuracy. For KNN, it's 96.83 and 96.81 respectively. For RFC, it's 96.61 and 96.70. And for SVM, it's 97.60 and 97.70. Also, the error rate has to be kept in check so that no major error occurs in the application using the handwritten digit recognition systems. So, minimization of error ultimately leads to higher accuracy rate. So, the graph shows the error rate for different classifiers. For KNN, it's 3.19, RFC 3.30, and for SVM, it's 2.30. Now, let's see the demo of this project. So this is the code for handwritten digit recognition. So basically here we'll be loading the input data set, the training and the testing data. This function print metrics is used to print the validation data metrics and also the test data metrics, which is accuracy, confusion matrix. So these are the functions for KNN, SVM and RFC classifiers. So here is the result for the KNN classifier. So for the validation data, the accuracy is this and the confusion matrix is this. For the test data, here are the accuracy and confusion matrices. These are some of the predicted labels. So similarly for SVM classifier and also the RFC classifier, the test results are displayed.